Hi, everybody. It's Professor Mitchell. We're continuing with Chapter 3 today and talking about Section 3.2 on measures of variability. Measures of variability show how much spread is present in the data. So if you think back to the last section, we looked at this little example of finding the mean, where one sample had values 999, 1000, 1001, and the other one had values 0, 1000, 2000. So both of those samples have a mean of 1000, but obviously they're very different samples. And in this section, we're going to look at how you can distinguish those because one of them is a lot more spread out than the other one. So there are three different measures of variability that we'll talk about. The first one is very simple. That's called the range. And then we'll talk about the variance and the standard deviation, which are very closely related to each other. And we'll talk about how to do those for a sample and for a population. We will probably be doing, actually calculating these a lot more often for samples, because usually you don't have all of the population data. So again, the range is the simplest measure of variation. It is simply the difference between the highest value and the lowest value in a data set. So in this example, which you can see here, you have data values ranging from 1 through 13. So the range would be 13 minus 1, which is 12. That's all there is to it. So it is the simplest one, but it's also the one that maybe gives the least amount of information. Because again, I could change all of those middle values to anything I want as long as they're between 1 and 13. I could make them all 8, or I could make half of them 2 and half of them 12. And the range would still be 12. Okay, so the range only depends on the highest value and the lowest value. So for that reason, it is somewhat limited. Okay, so advantages, again, very easy to calculate and understand. Disadvantages, only based on 2 numbers in the data set. It is sensitive to outliers, all right? If you change the 13 to 1000, you get a very different range, okay? But as I was saying a moment ago, if you had changed some or even all of the values in the middle, the range would not change. All right, so let's go ahead and talk about the more complicated ones. And really the variance is the one that you are gonna need to work to wrap your head around. Once you understand the variance, the standard deviation is very, very simple. So don't be intimidated by this formula, all right? It's not quite as horrible as it looks. So this says to calculate the sample variance, which is called S squared, you take the sum, remember the capital letter sigma stands for sum, of a bunch of numbers that have this form. And then after you've done that, you divide by the sample size minus 1, okay? So what is this thing that we're adding a bunch of them together? Well, down here you can see that each one of those terms without the square is the difference between each data value and the sample mean. So in order to use this formula, the very first thing you have to do is calculate the mean of the sample. Okay, this will make a lot more sense when we look at an example. All right, I'm going to show you this example 2 different ways. This right here is not my favorite way to do it. All right, so I added a new slide. I actually added a few new slides to this section. So if your sample data consisted of 4, 6, 8, 9, 11, 12, 12, and 18, first of all, I'll leave it to you to verify that the mean of that sample is 10. So what that formula is saying to do is to subtract 10 from each and every data value. One thing I noticed here, I noticed this in the last section also, this is kind of a computer glitch. That should be 3 dots there, and it turned it into a box. So I apologize for that, but I'm actually going to show you a different way to write this that I think will make it easier. So you subtract 10 from each and every data value, you square all of those differences and add those all together, and then finally divide by the sample size minus 1. So in this case, that comes out to 130 divided by 7, which to 3 decimal places comes out to 18.571. That's the variance. It measures the variability or spread of the data points around the mean. Now, a really excellent question to ask at this point is, okay, 18. What does that mean? I mean, what if it had been 2? What if it had been 100? I mean, what is that 18 actually measuring? Like 18 of what? And we'll talk about that a little more later. First, I want to show you, this is more like how I actually calculate the variance. So I do it in the form of a table. The first thing I do is I list my data values, okay? The second thing I do is calculate the mean. So that's right here. Now I'm going to subtract the mean from each and every data value. So 4 minus 10 is negative 6. 6 minus 10 is negative 4. 8 minus 10 is negative 2, et cetera, et cetera, et cetera. One thing that I should point out here, and I wish I had written this in my table, a really good way to check your work at this point. Where is my pen? Let's see. Here we go. A really good way to check your work at this point is to add these numbers here together. Those numbers should always, always, always add up to 0. All right? If they don't add up to 0, that means something's wrong. Now, let me just say this. Sometimes the mean will come out to a decimal. Oh dear, lost track of my mouse. Okay, so here's a trick for finding my mouse. Okay, there we go. All right, let's see. Let's undo that last drawing. There we go. Okay. Sometimes the mean will come out to a decimal, and if you round that decimal, these things might not add up to exactly 0, but they should add up to something very close to 0, like 0.01, 0.02. If they add up to 5 or 6 or 17, that definitely means something's wrong, okay? All right, so I guess that's the third step, right? Step 1, list all the values. Step 2, calculate the mean. Step 3, subtract the mean from each and every number. Okay, so step 4 is to now square all of those numbers. And there's something really important here that I want to point out to you, which is that the square of negative 6 is 36. It is not negative 36. So you should never, ever, ever have a negative number in this last column. And I just lost my mouse again, and it's going to be a little harder to find this time. Give me just a second. Nope. There we go. Found it. Okay. I always have to remember to turn the mouse back on as soon as I type or draw something, and I usually don't remember. Okay, so you should never, ever, ever have a negative number in this column. Okay. So you square all of those numbers. That's step 4. And then step 5 is to add them all together. So you remember that 130 that we had on the last slide? That's the same thing. I just think it's a lot easier to do it like this. I really strongly encourage you to do it like this. So again, 130 divided by 7. I wrote 18.6. Most of the statistics books that I teach out of say to, when you're writing an answer, to round that answer to 1 more decimal place than is in the original data. So if your original data is whole numbers, your variance would be reported to 1 decimal place. But if you're doing online homework, for example, on My Lab and Mastering, they are very good about telling you how many decimal places they want you to round it to. So just be sure to pay attention to those instructions. All right, let's see. I've got a couple of things to erase here. Okay, so that brings us to the standard deviation. The standard deviation is just the square root of the variance. So again, most of the work is in calculating the variance. That might take you, 2 or 3 minutes. But then once you have the variance, it's very easy to find the standard deviation, just square root of the variance. That's it. The standard deviation has the same units as the original data. So pretend for a second, let's see. Oops. Pretend for a second that these were prices of something. Then the standard in dollars, all right? The standard deviation then would be in dollars. This number here would be in dollars squared. And I don't really know what that means. So the standard deviation is reported a lot more than the variance is. All right, so to find the sample standard deviation, again, it's just the square root of the variance. You can kind of ignore the scary formula at this point because you've already dealt with the scary formula and found the variance, okay? All right, so in our example, we already found that the variance was 18.571. Now let me say something about this. Even though I reported my answer as 18.6, I would absolutely use 18.571 to calculate the standard deviation. In general, when you're doing statistics, and this goes for any kind of science, anything where there's a lot of calculations involved, you shouldn't round anything until you get to your final answer, okay? So if they were asking for the variance, my final answer for the variance would be 18.6. But when I'm finding the standard deviation, I would do the square root. I would really do the square root of 130 over 7. And then I would probably round this to 4.3. Okay, but again, just look at what the directions on your homework say. Okay, so what I would like you to do now is pause the video. Listed below are the weights in pounds of 11 players randomly selected from the roster of the Seattle Seahawks when they won Super Bowl 48. Find the range, the variance, and the standard deviation. Okay, so pause the video, take as much time as you need, and try that. Hopefully you took some good notes on the last example. And so when you're ready, just unpause the video and we will compare notes. All right, so hopefully you've had a chance to try that. Number 1, really easy. The range is 305 minus 189, which is 116 pounds. Notice I wrote 116.0 because, again, I'm used to one more decimal place than you see in the original data. Okay. Now, it says first method. I haven't shown you the second method yet, but we're getting to that. All right, so let's look at this. Here are all of my data values. So the first thing, hopefully, that you did after you wrote them down is you found the mean. And for the mean, I got 231.09. All right, so this time we are dealing with a decimal. All right, I will never, ever take your calculator away in this class. All right. Another thing that I want to say for any of you who might have taken statistics before, there will come a time where I'm not going to care if you do the variance and standard deviation by hand like this, or if you use Excel or a graphing calculator or some other kind of shortcut. That day is not here yet, all right? So whenever I test you on this chapter, I am going to want to see you doing it like this, or possibly using the second method that I'm going to show you here in a minute. So when you subtract the mean from each of these values, you get these numbers here. Notice some of them are negative and some are positive. That's just about always going to be the case. And then the next thing I'm going to do is square all of those. Remember, no negatives. We're squaring the negative number. The square of a negative number is a positive number. So you get all of these squared differences, and when you add them together, you get 19,236.9. That's been rounded a little bit. When I divide that by 10, which is one less than the sample size, that comes out to 1,923.69. So if I'm reporting that answer, I'm going to report it as 1,923.7 pounds squared. All right, as weird as that sounds. And then for the standard deviation, just take the square root of that number, and that rounds to 43.9 pounds. So the standard deviation of this sample of 11 Seattle Seahawks players is 43.9 pounds. Whatever that means, we'll talk about it later. Okay. All right, here is a second formula, and you might be looking at this and thinking, shortcut, that formula looks even worse. Well, believe it or not, it is actually easier, all right? So it will always give you the same answer, but for hand calculations, which is what we're doing in this chapter, this is an easier formula. Hopefully I will convince you of that when I show you an example, okay? So for the variance, you do s squared equals the sum of the values squared, so square each value and then add those all together, minus, so what's the difference between this and this? In this case, we're adding up all the values first and then squaring the answer, all right? So you take that number, divide it by n, which is the sample size, and then divide the whole mass by n minus 1, one less than the sample size. And again, the standard deviation, just the square root of the variance. So once you've found the variance by whichever method you like better, take the square root to get the standard deviation. Okay, we probably won't use this formula all that much. It's very similar. This is for the variance of a population. This is used when the data set represents an entire population rather than a sample. So really there's only two differences. Number one is notation. For populations in general, we usually use Greek letters. So instead of an S here, we use the Greek letter sigma. This is a lowercase sigma. And instead of X bar, we use mu, which remember from the last section is the population mean. Now the big difference, this will actually give you a different answer than for the sample variance. Instead of dividing by one less than the sample size, you divide by the population size. You don't do -1 for a population, okay? All right, so I'm not gonna do an example using that formula. What I am going to do instead, oh, and then this is your population standard deviation. Again, it's just the square root of the variance. These are your shortcut formulas for population, variance, and standard deviation. The only difference is when it was for sample, you had an n minus 1 here. So in this case, they're both n. This one here was always an n, right? Okay, so here's an example of using the shortcut formula, and then I'm going to give you one to practice. Suppose there are 6 courses with the following student sizes: 34, 25, 41, 32, 25, 29. So I list those data values, and then I list the squares of those values. So to use the shortcut formula, your table only needs 2 columns. Another nice thing about this formula is you don't have to calculate the mean, all right? And oftentimes you don't have any decimals get involved until the very end. So add the original data values together. In this case, that gives you 186. And then add the squares of the data values together, and that gives you 5,952. All right, so let's just skip right down to the formula. Oh, they're doing this one as a population. Okay, that's fine. So I guess the assumption is that there are 6 courses and that's all there is. All right. Okay, so you have the sum of the squares, which was 5,952, and then you have the square of the sum, which is 186 squared. That comes out to 34,596. You take that big number and divide it by 6, which is the population size. And then you divide that difference by 6. So 34,596 divided by 6 comes out to 5,766. And when you subtract these two numbers and divide by 6, you end up with 31. So 31 would be the variance of the population, and the units for that would be students squared. All right. Each of these is a number of students, so variance would be students squared. Let's see, did they do the... No, they did not do the standard deviation, but the standard deviation would just be the square root of 31. Let's see what that is real quick. The square root of 31 is about 5.6 students, okay? Rounded from 5.567764336, blah, blah, blah. All right, so now I would like you to try using the shortcut formula, which I bet you will like better. Use the shortcut formula to find the variance and standard deviation. We already found the range, and that has nothing to do with this formula. Find the variance and standard deviation of the weights in pounds of 11 players randomly selected from the Seattle Seahawks. So there's those same numbers again. I'll ask you to pause the video and try that, and then we'll come back and compare notes. All right, here we go. So notice it says second method. All right, that actually makes sense now. So again, just 2 columns. First column lists all of the data values. In the second column, list the squares of those values. Add the first column together, you get 2,542. Add the second column together, you get 606,670. So you put those in the formula. The sum of the squared x's comes out to 606,670. The square of the sum of the x's is 2,542 squared. We're going to divide that by 11. So when you crunch these numbers on top, you should get 19,236.91. That's rounded a little bit. And you divide that by 10, and you get the same answer that we got before. I've rounded it to 1 decimal place, 1,923.7 pounds squared. And then this part is no different from the first method, right? The first and second methods are only different for the variance. Take the square root of the variance, and it still rounds to 43.9, excuse me. Okay, so we'll close very, very briefly with looking at how Excel does this. I would say for now, it's okay to use Excel to check your answers. But again, I want to see you doing it by hand, at least while we're in chapter 3. Later on in the semester, I will encourage you to use Excel to calculate the standard deviation. So the Excel functions for the sample, variance, and standard deviation are var.s, S for sample, and then in here you put a range of data values like A1 colon A15. Or to cut right to the standard deviation, you do stdev.s and put a range of data values. And in the less likely event that you're looking for the population variance and standard deviation, you would just put a P instead of an S. And the other way that you can find variance and standard deviation is by using the descriptive statistics tool. So the descriptive statistics tool gives you a whole bunch of statistics, and among them are the standard deviation and the variance and also the range. Okay. So I believe that's it for section 3.2. We'll see you next time.